Good evening, sir. Good evening, sir. We can't hear you, sir.
Now, is it audible, madam?
Yes, sir.
Yeah, thank you. Thank you.
Shall we start the session, sir?
Yes, madam.
Good evening to all. We are assembled here for the 2-week multidisciplinary workshop training program on research methodology and data analysis organized by IQAC of ANNAMALAI University. Good evening to all. Today we have our resource person, Dr. Vishnu Vardhan, sir, from Pondicherry University. Sarah has been working as an associate professor, Ramanujam School of Mathematical Science, Pondicherry University. So this is the third day Sarah is coming here. For Sir, it is about 62nd session. We are very happy to have you, sir, today. Your session on R programming was very interesting. It had got very good feedback from our participants.
Thank you.
And we are very eagerly waiting for this today's session. Please take the session, sir. Please, sir.
Yeah. So thank you once again for the organizing team, IQAC team, and all the participants for patiently listening to me. So let us continue yesterday's discussion, what we had on menu-driven analysis of menu-driven access in R programming. Okay, and I'm so happy that most of the participants so interactive with me in last couple of sessions. I expect the same in the next this session as well. Okay, now I'm about to share my screen. Okay, hope the screen is visible now. R Studio, yeah. Okay, so now we were in the discussion of R Commander. So how to install that R Commander and how to get the menu driven approach? We have to type library RCMDR. Now I'm loading the thing. Now the packages are getting loaded. And now if you see, now you can see the R Commander. Okay. Now, first what we have to do before going for some more analysis in R Commander, we need to load the data set. How to load the data set? Data, import data from Excel file. In that, click OK. And you have to choose the data. The data is acculturation, stress and depression data. Now the data set is loaded. Clicking view data, you can clicking data, you can see the data set here, which is loaded. Okay, there are around 268 samples across various columns. Okay, now let us come back to the data file. So yesterday what we started is we tried to create some sort of a analysis out of this particular table. Now we'll go with a contingency table, two-way contingency table. Let us try to do. Now when we go with a two-way contingency table, Now let us take depression type is one variable across the row. And let me see, I want to see how many males and females are there. Now click on OK. Now I got a table here that out of the total 268 distribution is this. Out of 52, out of 42 people who are under depression type, 26 belong to female, and non-depressive also there are majority of females. At the same time, other type of depression status also females are at the higher level. Okay, so by default chi-square result will come, but let us try to make it in a different way. Two-way contingency table. In statistics, remove this chi-square test for independence, because in total every time there is no need to for an association analysis. Okay, now at the same time, if you want a row percentage or column percentage, it purely depends upon the objective. See, now I want to see under each depression type what is the percentage of male and female. Then I choose row percentage, click on OK. Now I got that 61 point, this is the total, and this is the row percentage. 61% of the females are under the major depression category. Around 70% of females are of other depression category, like this. Okay, now yeah, let us move further. Now let us try to see some sort of analysis. Okay, hypothesis testing. See, my presentation here is not to show you that in what aspects R is better than SPSS or SPSS is better than SPR, because this is the commonest question that comes in every talk, that which one is better. So the better, inferior, superior of the softwares is not the point of interest for me. Having knowledge in multiple software is an essential part. Okay, and how easy way we can execute each technique and how to present the findings is of prime interest. Okay, now yesterday what we did is we tried to compute summary statistics across gender with respect to homesickness, fear, all these things, culture shock, and one more variable. When we did so, it was noticed that majority of the females are the mean fear, mean culture shock, mean homesickness was higher in the females than the males. Now at the time we had a thought that if we define that as objective to investigate further, that whether that difference between the mean fear of females and males, mean homesickness of females and males is to be significantly considered, then we can do some sort of a hypothesis analysis there. We can define an hypothesis stating that there is no mean difference between the females and males with respect to fear, homesickness, culture shock, and some other variable like this. 1 second. Now, is my voice clear now? Is my voice clear? Yeah, thank you. There was some USB related issue. Thank you for notifying that. So what I was telling, we were about to define the hypothesis with respect to fear, homesickness, something like this. Now to verify that statement, go to statistics, means. Now let us try to see with respect to domicile, the domestic and international participants across different continuous quantitative variables. Now groups here, let me see with respect to gender, and here one response variable, let me take with homesickness and go to options, because I'm not sure whether the difference will be less than 0 or greater than 0. Then difference between female and male, let me go with a two-sided. I'm assuming equal variances. Okay, and now clicking OK. What did I do now? Let me repeat again. Let me repeat again. Statistics, means, independent sample t-test. Independent sample t-test. I choose one of the category grouping variable as gender, and the variable under comparison I have chosen as homesickness. And then the next link is going to the options tab, selecting without changing any other option, selecting assume equal variances. Now press click OK button. Now the results are here. Where the result? The mean homesickness of female is 10.17. Mean homesickness for females is around 8.62. And the total p-value is observed to be 0.0021. Now, what is the comparative statement here? If p-value is less than 0.05, then it indicates that there is a significant mean difference between females and male with respect to homesickness. That is the first thing that we can write. The next thing is, on average, the mean homesickness is more in females than that of males. Okay, so this is one thing that we get from this outcome. Okay, likewise, now let us try to repeat this procedure with another grouping variable, that is means independent sample t-test. Instead of gender, let me take the domicile, whether they belong to international or a domestic, and let continue with the same homesickness. Okay, click on OK button. Now the result is here. Okay, so the mean homesickness in the domestic respondents is around 8.02. At the same time, the mean homesickness in the respondents who are from other than Japan, international, I mean Southeast Asia, East Asia, southern part of Asia, their homesickness is comparatively higher than the local respondents. Now this difference, the difference of 8.02 and 10.13 is a notifiable or a noticeable difference, and it has its impact statistically, that the mean homesickness of the international respondents who are residing in Japan, they have high levels of homesickness than the local residents, local respondents of the study. So that how we are concluding, basing on the p-value that we have observed here. Now the next question comes, I want to see the same mean comparison with respect to the depression type. See, the depression type is not displayed here. Why? Because the independent sample t-test is for the purpose of comparing a quantitative variable across two groups only. Across two groups only. That's why in R commander, one of the advantage is that when you are going with a independent sample t-test analysis, then the groups with only two categories will be displayed here. Okay. Depression, yes or no. Okay, like all of these are yes or no. Gender, male, female, domicile, international and domestic, internet, intimate, yes or no, yes or no. All these are yes or no kind of a categorical variables only. That's why they are all displayed here. Now, if I wish to do the comparison of homesickness or fear or any other relevant variable across more than two categories, then what I have to do? I have to go with mean one-way analysis of variance. Why one-way analysis of variance is that more than two groups comparison, but across different depression types. Across different depression types. So click on that one-way ANOVA. Now we got. Now see, depression type has come. Now depression type has come. Now let me choose this as ANOVA model 1. Let it be like that. Now select the homesickness. Okay. As of now, don't select any other thing. Just let us run the basic ANOVA and then try to understand. Now click on OK button. Okay. Now see this outcome. The mean homesickness is highly observed with respect to the respondents who are having who belong to the category of major depression. Okay, and next comes with other type of depression. People who do not have the depression, their mean homesickness is comparatively lower than the other depressed respondents. Okay, and coming to the p-value, it indicates what? It indicates that the mean homesickness differ among the three categories of the depression types. Means the mean homesickness is not uniformly noticed across the three different categories of the depression type. They differ in terms of mean. Okay, that's why the hypothesis is mean homesickness of major depression is equal to mean homesickness of no depressed people is equal to mean depression homesickness of other type of depression category. That is your null hypothesis. Okay, now whenever you observe a significant p-value, then you need to go for further investigation. That is what we call post hoc comparisons or multiple comparisons. Okay, we should not stop the analysis of variance technique here itself. We need to move further if we observe a significant p-value in the ANOVA table. Okay, significant p-value in the ANOVA table. Now, how to do that post hoc comparison? Again, go back to this statistic. Means one-way ANOVA. Here you have a button called pairwise comparisons. Click that button. Okay, click that button and press OK. Now it will display table like this along with the ANOVA table. Along with the ANOVA table, it will display a multiple comparison outcome using Tuckey's test. Okay, now this is the difference. You see the hypothesis here. The main in the first class of mine, I said the major hypothesis will get divided into if there are three groups, it will get divided into three sub-hypotheses. If it is four groups, it will get divided into six sub-hypotheses because 4C2 combinations. Okay. Now here, the mean homesickness is being compared between the respondents of non-depressed and respondents of major depressed category. Okay. Now the second comparison is between other depressed respondents and majorly depressed respondents, other depressed respondents and non-depressed respondents. Among all these comparison, the star mark is noticed only with respect to the non-depressed and major depressed. Why so? Now the C, if you see here, the mean homesickness of major is around 11.14 and non-depressed is 9.23. The difference of this 9.23 minus 1.14 makes some sense that the mean homesickness is at higher level and observed at higher level in the majorly depressed candidates than the non-depressed candidates. So that's why the p-value is observed to be significant, Okay. Now likewise, you can just go on, and one more thing is there. Where is that graph? Yeah. This is what another graph. You're able to see the graph? You're able to see the graph?
Yes, sir.
Yeah. Now, if you see, what does it mean? This is nothing but this dot is the average difference between, this dot represent the average difference between the comparison groups. That means, that is, let us take the mean difference is 11.14, 9.23. So 9.23 minus 11.14 is somewhere 1.78. That is your dot. And how much it will vary? So that creates a confidence interval. This is the lower confidence interval of the mean difference, and this is the upper confidence interval of the mean difference. Okay. So this is just to summarize the outcome. Fine. Till now, is that fine? Any doubts as of now? Till now, any doubts you have? Okay. Any question you want to ask as of now? Other than comparing between R and SPSS, SPSS and Excel, don't raise such questions. They are all very small questions that cannot be answered, and that doesn't have a common observation there. But any technical subject wise, you can raise. Someone raised a question. Subhashini Raman. Yeah, madam.
Good evening, sir. Sir, actually, if we want to work on this, which software should we download? Is it free? Or
it's freeware. It's freeware. That's what I said.
Is it R Studio which we have to download?
R and R Studio. Yesterday I have shown how to download it and how to install it. So you have to install both R and then R Studio. Okay. And just use one command called library RCMDR so that you can use this kind of a menu driven approach.
Okay, because yesterday I think because of the internet I missed the initial part.
That's fine, no problem, no problem.
I downloaded R Studio, so I have.
No, you have to first install R. Okay. You have to install. You should download R also. First install R, then install R Studio.
Okay, then library R.
No, if you have to install a library also. Like you go to this install button. In that you type RCMDR. It will come automatically. Select this and click on install button. Okay.
Okay.
You got this?
Yes, sir.
Once you do that, once the installation is done, then you have to use this one line. That's it. You have to use this library RCMDR to enable this kind of a dashboard. Clear?
Yes, sir. Yes, sir.
Yeah. Yeah. Any other doubt like this? I mean, related doubts, subject related doubts. Okay. Now, if you want to ask any, let me do one thing. I'll spare 5 to 10 minutes now for answering your questions. Not necessarily to my talk of, I mean, discussion part, but in general, if you have any kind of a doubts in statistics related to modeling, inference, basic exploration, graph, any doubt you can raise in this. Now the time is 4:30, I think 4:25. Till 4:35, we will try to utilize this time for reaching you out in a different manner. Okay, rather than I will cover another topics also, but before that, let me try to reach you out with your with the doubts what you have in your mind, other than the topics I cover. You don't have a doubt at all? You don't have doubts in the way you work related to statistics? Can we do sample size calculation using this software? That's a good question. I don't think so. But using this menu driven, we cannot do, but with the programming, we can do. Okay. With this dashboard, we cannot do sample size estimation, but we can do in R. We can do in R. Okay, I have done it for multiple occasions, like determining sample size for two group comparison, determining sample size for more than two groups, then repeated longitudinal studies, different research designs. I have generated sample sizes, and I have given the determination of sample sizes required for conducting the study. Okay. How to export the output to the Word? But as such, directly we have to copy this. Whatever all required, you have to paste it in a Word directly. Okay. R Studio is same. R Commander is a library. It's a package. R Studio is the engine or a kind of a platform where you have hundreds and hundreds of packages to carry out your required analysis. And what is this loading? Yeah, it will come. No, once you see this error message, it might have asked you yes or no. You click yes, it will continue further. I think this question is with Selva, Mr. Selva. Okay, nothing to worry about that. Yeah, 4.1.2 is the latest version of R. Correct. Correct. Yeah, someone raised the hand.
Hello.
Yes.
Good evening, sir. I'm Chitranjan. I'm
Chittaranjan.
doing.
Yeah. Tell me, Mr.
Yeah, I'm doing research on impact of alternative environmental education program on students' connectedness with nature, sir.
Student connectedness with nature.
Yeah. So
Okay.
I want to develop an alternative environmental education program for which will be an effective tool for increasing connectedness with nature.
Okay.
By using one of the tool, that is CNS, connectedness for nature for sustainable implementation of environmental education in schools of Goa.
Okay, fine.
So my hypothesis is that there is no significant difference between alternative environmental education program on students' connectedness with nature tool, which is based on age and gender of the students.
No, I mean, is that your research objective?
This is a hypothesis, sir.
This is hypothesis.
research
Now, what is the
yeah.
quantitative? Like here, we have used homesickness, we have used fear, we have used culture shock as a quantitative variable for comparison. Clear?
Yes, sir.
So
Yeah.
likewise, how many dimensions you have in your questionnaire?
I have.
Now, if you have any
chosen,
hesitation,
three different.
1 minute, Mister. If you have any hesitation to
Yeah.
share in this public forum about your study, which is going on, you can reach me out. Okay.
Yeah.
To my phone number.
Okay.
Clear.
Okay, sir.
Okay. If you are hesitant, if not, you can ask me here itself. No problem. My number is given.
No, I have selected 3 different classes, sir.
You have selected 3 different classes. That's good. Okay. And a questionnaire is distributed to the students.
Class 5th. Yeah.
Right. And once the questionnaire is distributed and the responses have been fed in Excel and the total scores are derived. Clear?
Yeah.
Okay. Now you want to use that scores across gender, across 3 different groups.
And village and rural and urban area also.
Okay. So 3 different areas are also there. Village, urban and rural. Okay. Then you can do a lot of inferential statistics. Now, what is your doubt now?
My doubt is, sir, now before going for collection of sample and all, can I go for this analysis by putting some values, because we are not used to SPSS and all.
No, don't go. We should, unless the data is there, we should not do with, we can do the analysis with a mock data, but that cannot be taken as a final result. Okay. But,
no, it will not be final, just for the mock
but you have to determine the sample size, no? How many samples in each group you want to have, that should be determined.
Yeah, I have taken each class as 40 students. So we have 3 classes. So 40 students, 120 students are there. 3 different classes.
Yeah, then go for data collection, share the questionnaire and get the data. That's it.
But again, sir, I wanted to take this particular 3 different groups in one school as an ideal school. But can I then generalize the statement that such thing is also prevalent?
You cannot. You cannot, because school to school, children to, I mean, age group to age groups, class to class, the perception levels of that particular questions by the students do vary. Okay. Instead, what you can do, you can select around 4 to 5 schools or 10 schools of particular class 7, 8, 9th. Okay. And then pull the information, and then you can try to generalize related to that private or public schools, like that only.
Okay, 10 would be ideal number, sir.
Yeah, 10 schools, in that you can choose with private and public. 7th, 10th class or 9th class you can select. Okay, then you can have some sort of a sampling mechanism to select the students from each school of public and private. Okay.
Okay, sir. Thank you, sir.
Yeah. Not necessarily 10% of population, because once you frame communities and then select the schools, it will become kind of a stratified random sampling. Okay. It will not be a purposive sampling. Okay. Each class, I mean, 10th class will be a strata. In the 10th class, multiple schools will be there. From there, you need to proportional PPS sampling we have to. In stratified sampling, proportion to size. population proportion to size percentage you have to derive, and that particular percentage of students only should be selected from each public and private schools of the class 10th. Okay. 10% of population will come in a survey based. Okay. You got Mr. Chittaranjan? Chittaranjan.
Yeah, this is not, this is not survey, sir.
No, that's what one of the participants raised 10% of the population. That's why I made it more clear that each school, each class will become a strata, and from that proportionally, we have to derive the samples from each class. If the strength is 50, maybe 15 or 20 samples from each class and each school should be taken as a samples and data to be collected from them only. Okay.
Okay.
There is a separate formula, madam, for that.
And the program which I am,
please.
sir, the data which I am alternative environmental education program that I am developing, sir. How to validate that program, sir?
No, program validation purely depends upon your results, outcomes. Okay. Before that, you should validate the questionnaire. Reliability of the questionnaire you need to verify. That's why you need more samples. So you have to share the questionnaire across multiple
I already
schools.
have the questionnaire. Sir, I already have a questionnaire which is developed by some foreign author, sir, where in Illinois University.
But the education sector in overseas and our Indian sector are a bit different, right? The perception levels also do vary, but that should be localized, and we have to verify the reliability of those questions in the localized environment, a school environment. Okay. So at least you need you need to involve more number of samples. You need more number of samples, and then accordingly, first what you have to do is you have to do a pilot study.
Okay.
So basing on that, you will come to know the reliability of the questionnaire using Cronbach alpha on that sample. Like, let us take 50, let us take 75, something like that. Then accordingly, that questionnaire can be slightly modified with the version, and then you go with that. Okay. You got
reliability,
now the flow?
I have to, yes, sir. Yes, sir. Thank you, sir.
Yeah, hope I have answered. Right? Yeah, how to exactly define the population count? Can you give an example? It purely depends upon the size of each class. Suppose in his case, he is defining only the 10th class. Let us take, there are in a state, in a particular district, let us take there are 30 schools, of which 20 are private and 10 are government. Okay, so take the strength in each government school and each private school will become the count of the strata, and proportionally you have to define that and take the samples from each of the private and public schools. Like that it will come. Yeah. Any other doubts?
Sir, this is Deepa, sir, which I have asked the same question, sir.
Yeah, madam.
Sir, so you mean to say that we have to exactly need to have a statistics over how many schools or how many colleges of are there in a particular state or district which we are going to select?
Correct.
Okay.
Definitely that count will be there.
Oh, so from where we have to take the statistics from the Google and we have to take the population?
It will be the education department where you can get. Okay, in each school, what is the strength of 10th class? What is the strength of 9th class? How many sections you have? Everything can be done. No. Okay. Not necessarily secondary source, but with the primary source, with some, I think somewhere. Yeah. So like this, from education department, you can request them. They will give the data definitely. Or with your school network, you can try to get the count. particularly the answer what I have given is for this kind of a study. Suppose if you want to see the heritage monument of a particular Goa state or a Pondicherry state or any Tamil Nadu like this, then the stratified random sampling, simple random sampling, cluster sampling, all this sampling mechanism will not work. There you have to go with a quota sampling. People who have visited the heritage monuments and get the impressions, perceptions out of such particular public, then you should visit the people who have come across the monument, heritage monuments of respective places. Then that will become quota sampling. It's a kind of a pure non-probability sampling. Likewise, how the design, research design you define accordingly, your sampling design will get defined. Another example, suppose if you want to read about ecotourism spot of a remote area in a particular village or a state, then what will happen? Your respondents will become only the tourists who visit that particular ecotourism, not the total population in the district. Again, that will become a quota sampling. Okay. So likewise, basing on your research design, either snowball sampling or a quota sampling or a simple randomized sampling, stratified randomized sampling, like that, the study designs do vary. Clear? Hope you got Deepa, madam. You got this, right?
Yes, sir. Yes,
Yeah.
sir. Thank you,
Yeah.
sir.
Yeah. Any other questions on any other topic or on the same sample? This sample size determination and sampling design are very crucial and sensitive. Okay, a care to be taken, utmost care to be taken.
Excuse me, sir.
Yes, madam.
Sir, this is Meenakshi Malik this side. Sir, I am just trying to choose this topic. Is it relevant? Can you make me clear about this?
Yeah, you can. No problem.
Sir, I have chose this child psychology in online education for primary classes during COVID-19 era.
Okay, that's good. Okay.
Yeah, and second one is learning in COVID-19 era in relation to primary schooling.
Okay.
And the third one is COVID-19 era, a technological drift from traditional to modern teaching.
Okay.
So, sir,
Now,
yeah,
yeah.
I want to, sir, I want to choose like any one topic from this. Is it relevant, sir? May I do like, may I start searching on this?
Yeah, you can. If you don't mind, Meenakshi,
Yeah.
let us, I mean, I have a lot of insights on the 3 topics that you have given. Okay.
Yeah.
If you don't mind, you can reach out to me to my mobile number so that I can give some inputs so that your outcomes and your ideas will not get it will be confined to you for the beginning of the study. Hope you got the point.
Okay. Okay, sir. Can you share your number?
I have already shared, but once again, let me share.
Yeah.
Okay.
Wait, sir.
But the sampling technique will affect because your ideas are very insightful. Okay.
Yeah.
So let us have some discussion on that separately. Okay.
Right. Sir.
But sampling technique will affect statistic lighting test. Of course, because of imbalance in the samples of, let us take gender, let us take number of samples in school. That's why particularly to my email ID, particularly to the case of Mr. Chittaranjan, I suggested stratified sampling, because when we take to percentage proportion size of each class, that balance will get maintained. Okay. Just like that, if you go on sharing the questionnaire, then the problem what you have raised will come. Okay, that's a good point. Any other? I'll take one more question, then I'll move to the other aspects, what I wish to plan. Madam, till what time I need? I have till that 5:30?
Yes, sir, 5:30.
Okay, so I'll take one more question now, then I'll continue my discussion with all of you. One more question.
So difference between convenience sample and quota sampling.
No, quota sampling, snowball sampling, or all comes under the convenience sampling only. Okay, quota is not where a particular like tourists visit. Okay, and then all these examples will come under the quota sampling. Okay, where your confined respondents will be available, that cannot be taken across the different public source. So such particular thing that we call is a quota sampling. Okay, like that you have a separate called snowball sampling, where you know one people, I will share that questionnaire, that person, he or she might be knowing the other people who are related to that particular study objective. Then I'll request them to share my questionnaire to get some more data. At the same time, I'll put a word that if they know any other people of this particular research study having idea to give the data, then the same questionnaire will be given across like that. So it will be like a chain. That is what we call snowball. Okay, and can we get R correlation in? Definitely not. We will be doing that. Next, I'm trying to do that only. Okay, correlation, regression.
Both correlation and regression we can do in R, sir.
Yes, yes. All statistical analysis we can do in R. Okay, I have shown you already. I mean, in menu bar, if you see this, you can see the correlation matrix.
Okay.
In fit model, linear regression is there. Non-parametric, all sorts of statistical tests that you do in various statistical software, all can be done here also. Okay, only my attempt is to show you that there is a menu driven option in this R programming also. That's it. Okay,
Can we use call Pearson?
yeah, Carl Pear also you can use.
Okay, sir.
Carl Pearson, Spearman, Kendall,
Yeah.
different options of correlations are also available.
Okay, sir.
Okay.
Okay, sir.
So can we move with this good interaction? Thank you so much to each one of you.
Thank you, sir.
We'll move further, right? Yeah. Now let us try to do some more analysis. Let me go with graphs. So far we have not touched that. Graphs. Let us go with histogram first, or box plot. Let us go with the box plot because most of you are very fascinated and interested to know of the box plot. Let us try to do with some other variable. What is that other variable? Social connectedness. Let us see. Social connectedness. How to do this? Go to graphs, directly box plot. In that you choose the variable of your interest, quantitative variable, because box plot should be applied for quantitative variables, and social connectedness is the variable that I have chosen. And let me click on the tab options. What values you need to have? I want X label, Y label, graph title. Let us do that later. Now let's generate the default template of the box plot. Now click on OK. Now I got the box plot here. See, what does it will tell? Now, this is the median. The dark horizontal line is the median, the third quartile and the first quartile. And the tail on its left is elongated than to the right, which means that, yeah, I think good answers are coming for me. That's nice. Okay, which means that majority of the data points are on the left side of the median and has more extended tail towards its left side of the median than the right. So this kind of a data is what we call left skewed data. And there is, what is this 215? 215 is not nothing else. It's just an outlier. It's an outlier. 215th sample is having a low social connected score, and it is apart, a distinct value when compared to the complete profile. It is called left skewed distribution, not negatively skewed. Okay, left skewed. Negative, positive, that comes with magnitude. Okay. Now this you understood? Now this is for the 268 samples. Let us try to generate across social connectedness score across what? Many things I can do. Let me select the social connectedness, and now I have that option here, plot by groups. Let us try to do with respect to depression type. Select that variable, click OK and press OK. Now I got, see. So when compared to the previous graph, this graph makes a lot of sense. What are the observations that we are getting out of this particular box plot? Number one, in the complete data, there are two outliers in the non-depressed respondents and one outlier in the other type of depression candidates. Now, more or less, second point, more or less, the data is not normal. Is my observation correct? The data is not normal in majorly depressed category, non-depressed category, and other depressed category. The data is non-normal. On what basis I am telling? On what basis I am telling? It's non-normal data. Basing on the median. Median should be exactly in the middle of this box, almost. Okay, more or less in the middle of the box. Then only the data is symmetrically or normally distributed. Now, if you see in each of the depressed category, the median is on the left, nearer to the quartile 1, closer to the quartile 1, and closer to the quartile 3. That is the second observation. Now, what is the third observation? The social connectedness is quite lower in the depressed candidates, majorly depressed candidates, and more or less little similar in the non-depressed and other depressed candidates. So, whenever, I mean, that is a tendency of the people, and one of the indication of the depressed people, severely depressed, mentally ill health people, that they don't move in socially. They don't want to connect in a normal social environment. Then definitely their social connectedness score will be as small when compared to the other category. Is my interpretation clear? You are able to understand and catch it out? Right. So now let us try to do with another setup. I want to go with again box plot. Let me try to do, let us reset it. Let me try to do with social connectedness and plot my groups. Let me do with gender, what it will tell us. See, social connectedness. Now, can I get some insights? Can I get some insights in this? Normally distributed? Yeah, slightly normal, because the Whisker is extended towards the quartile 1 in both males and females. So slightly left skewness is there. Okay, and you have outliers, two outliers, 47 and 215. That's good. And then what is another observation? Any other, some more observations do we have from this graph? Medians are almost similar. So the median social connectedness between males and females are almost irrespective of the gender. That's good. Thanks for that. Now, let us try to do some other things. Let us go with a plot of means. Plot of means. Okay, what does it tell us? Select factors, pick one or two. I want to see with respect to depression type, and hold the control button and select international domicile, and the variable here you have, let us select social connectedness. Okay, now let me see how the graph will come. Wonderful. This is what we call plot of means. Okay, this is what we call plot of means. Okay, now how to make, how we understand this? What this graph is trying to tell us? Can anyone make a interpretation out of this? Can anyone try? Looks like sociometric. Okay, it's what we call line whisker plots. In statistics, this is what we call line whisker plots. This is more what do we say, worthful in presenting your outcomes. It tells a lot. Okay. Now, can I get some 1 or 2 points out of this graph? Because we believe graphs are more explorable. Same median, where? It's a plot of means. Same median. It's incomplete. You're trying good, but still I need some complete thing. We have used 2 categorical variables to understand 1 quantitative variables. Okay. Male and female. We have not used male and female here. We have used domicile, domestic and international, and depression category. It's quite simple to see. Now this no is nothing but non-depressed candidates. Okay. In the non-depressed candidates, average social connectedness is almost similar, overlapping. Okay. And in the other depression candidates, social connectedness is slightly higher than the domicile respondents. Okay, slightly higher than the domicile respondent. At the same time, in the majorly depressed respondents, the social connectedness, the mean value of the social connectedness is comparatively lower in the respondents who are other than the existing country. What does it mean? When they are majorly depressed, okay, particularly the respondents, majority who have the low social connectedness, they belong to the major depressive category. Okay, like this. So this is what we call plot of means. Understood? How to generate, how to interpret. Is that clear? Yeah. Now let us move with some other graphs. Box plot, then you go with a scatter plot. Scatter plot is between 2 quantitative variables. Let us try to make some other variables, like you have perceived discrimination, and the other variable, let me take social connectedness. Perceived discrimination and social connectedness. Or let us try to make use of the fear. fear and social connectedness. What we have in options? We have many other things in options that will come later. Okay. Now click on OK. Oh my goodness. What is this graph? Does it make any sense? Fear and social connectedness. What kind of graph is this? What kind of a graph is this? It's a graph of scatter only, but fear and social connectedness are not at all related. We cannot understand a person. If a person has a high social connectedness, then definitely their fear levels will be low or high, like that we cannot relate. This is an example of absence of correlation. This is an example of absence of correlation. Understood? Now, let us try to generate some other graph. Graphs, scatter diagram, culture shock, and then any other variable. Let me select again social connectedness, click OK. Oh my goodness. This is also having almost zero correlation. Now let me do, no relation at all. Scatter diagram. Now I will introduce a new version, scatter plot matrix. Scatter plot matrix. So you do social culture, fear, guilt, homesickness. Let us try to do that. How? What is this? Something I'm getting. Let me redo with other graphs. Culture shock, reset. Culture shock, homesickness, perceived discrimination. And perceived hate rejection. Let me remove culture shock. Let me select homesickness, perceived discrimination, perceived hate rejection. Now this graph is what we call scatter plot matrix. Means this graph is between perceived discrimination and homesickness. 1 second. Yeah, so this is the scatter plot between perceived discrimination and homesickness. This scatter plot is between perceived hate rejection and homesickness. And this scatter plot is between perceived hate rejection and perceived discrimination. Now, how to understand this? And these are all the density. There are multiple groups within this. Okay, this is a bi-model. This is also a tri-model, and this is also a tri-model pattern. That means there are 3 populations, hidden populations within each variable. Now that will come later. Now observe this graph. Perceived discrimination and perceived hate rejection. What do you understand with this? What do you understand with this? Positive, some sort of a positive correlation, but there are some extreme values. There are some outliers. Sorry, there are some outliers. Yeah, they are positively correlated. Okay. So the practical sense makes that if anyone has a perceived high levels of hate or hate rejection, they feel that they are discriminated from the society. Or high levels of discrimination indicate that they are hated much or they have been rejected in the community or society they live. Okay. Similarly, when you take between this, some sort of a moderate, very weak correlation, absence of correlation. Likewise, we can make out all these things. Not much correlated, correct. Homesickness and with respect to discrimination, with respect to hate and rejection, they are not much correlated. Okay, now let us redo this in a different sense. Graphs, scatter plot matrix. We have selected the same three. Now click on plot by groups. I want to see depression type, or let me go with gender or domicile. That will make sense. Domicile, click that. Click OK. Now see. Blue or the domicile one, I mean domestic one, pink one or the people who are out of that particular country. Now, if you see this, majority, there are around 160 or 140 respondents from international respondents. Okay, and most of the people have highly discriminated, have been highly discriminated. Even though in the domestic respondent also, there are few samples where they have this perception. No, my attempt here is, that varieties of graphs can be generated. I will try to generate one more graph, that is what we call 3D scatter plot. Means two explanatory variable like fear, homesickness, and here I take culture shock. Let me create this button. I got this. Are you able to see this now? This is a 3D. Another fascinating thing is you can rotate, you can zoom in. Okay, I can zoom in. I can see the surface here, how the data points are floated in the surface. Generally, in a bivariate plot, you see only one dimension. This is one dimension, this is second dimension. When you take it scatter plot, data points will be here in the area, in this area. Okay, so that is what you are witnessing now. Okay, so high levels of homesickness, high levels of fear, you have high levels of culture shock, or high levels of culture shock and fear is creating homesickness. Understood? Nice, no? This kind of a graphs. You can zoom in and zoom out. Clearly you can see. Scale of the axis is taken automatically. You see this 4 to 20, 4 to 20, 3 to 10, like that. Okay, scale of the axis is automatically taken, but still we can move. We don't have no need to input. Automatically it will take from the data, minimum, maximum, and accordingly it will arrange. And one more thing, if you see, have you noticed one more feature here? There are big dots and small dots. Size of each dot is according to the data point. Okay, a smaller homesickness, smaller values of fear, and moderate values of culture shock, like this. So bigger circle, bigger dots, these are all not available in experience, correct? Okay, so bigger circle indicates what do you say, higher levels of culture shock, fear, and homesickness. Smaller circle indicates lower levels of culture shock, all these things. Now let us try to do this in a different way again. That 3D scatter plot, I want to plot this across same variables across gender. Okay, click that and see. Got it? With color. Okay. Now color differs. Pink are females, blue are males. Now you can see there are many males at the trajectory of this axis with high levels of homesickness, and then fear and culture shock, something like this. It makes sense, right? Yeah, that's nice question. How to put on this is save to file. Okay, first we have to generate the graph. Okay, now come to save the graph of 3D RGL. Now the graph is saved. You can name that and click save. Okay, that's it. Your graph will get saved. I have not saved. I will save it and do that now. Or, okay, 1 second. Save 3D graph. Now RGL graph, download, save. Now as a PNG, you can see here, RGL graph is saved as PNG, downloads, RGL graph. It is a static graph. It's a static graph. Okay, just first, what we say, I think I have tried once with save graph to file. 1 second. I think rotatable also we can save. I think it requires some animation. I will know that. I will just a minute. No, where is that? Did I saved it? RGL graph. It's a snapshot. It is in downloads.png. Okay. RGL. It's a static image only, but I have done it, but I'm not able to do now. Don't mind. Okay. That rotatable thing we can save. It has some separate options. I have done that. So likewise, you can do many other things. Okay. And next, let me, you want to see the Kruskal-Wallis test, depression type, and you have a social connectedness, homesickness or social connectedness. Let us take discrimination, click on this. Your output comes here. Okay, so this is what, and the more interesting thing, models. This is graphs, distributions. Anything else you want to see now? Bar chart you want to see? Click on the bar chart. And then these are all usual routine. What is conditional plotting? That's a good question. Conditional X by conditional plot. Right. Yeah, that's this is quite interesting now. Select one or more quantitative variables. Okay. Let me select cultural shock. Let me select fear. Okay. Now let us try to do in a simple way. Only culture shock we take or fear we take, and the response variable. Fear, if more fear is there, let us try to understand that or culture shock and fear. Response variable is nothing but your dependent variable. Explanatory is nothing but your independent variable. Okay. Now this is conditioned on what? Conditioned on culture shock on fear. Yeah, correct. Culture shock, because high levels of culture shock may give us more understanding about what level of fear they may have. Something like this for just illustration purpose. Okay, conditioned on, let us take all the categorical. I want to see with the domicile. Conditioned on domicile and what group? Let me take here gender. Click OK. Now this is the graph we get. Are you trying to understand this? How to infer? That's a big question. Okay, we can do that. We can do that. Just what variables we have taken. What variables we have taken? We have taken culture shock as an independent variable and fear and as on dependent variable. So obviously, just imagine the same graph as a 2D scatter plot. As a 2D scatter plot. Now, x-axis you will have the independent variable, y-axis you will have the dependent variable. This is the thing. Okay, now once we do that, now we are dividing the presentation across domestic separately, international separately. That means this is the number of samples belonging to domestic respondents, where this is the scatter plot is for culture shock and fear. And this is also another scatter plot between culture shock and fear, but taking separately the international respondents. Till now, is that clear? Yeah, it's a three-way. The major scatter plot is further divided. First partition is with respect to the domestic and international respondents. Second partition is with respect to the gender depiction. Okay, gender depiction. This is what we call conditional plotting. We can reduce this. We can reduce this complexity in what way? Just reset. Now you select discrimination. Respondents is social connectedness. You can have only one. I want a condition. I don't want any condition here. Just I wanted to have with respect to domestic. See, like this also we can do. Understood? Blue and pink colors are the given for, in the previous figure, they are given for male and female. Now in this graph, they are given for domestic and international respondents. Now, can you infer something out of this? Yeah, condition will split the proper presentation of data points. Okay. Now, what inputs are, how to understand this graph? Can you? Red rightmost is high on perceived discrimination. Okay. Red is nothing but your international respondents. Let me make it bigger. Is that clear now? Is this fine? Let me take it the board. Yeah. So perceived higher levels of perceived discrimination will have a lower levels of social disconnectedness. Okay. And it is a negatively correlated. And moreover, intern has high beta. Intern means, oh, international. Okay. Is high. Okay, I mean, majority of the samples are international respondents. So they have higher levels of discrimination. So they have a lower levels of social connectedness. Clear? You got the point? Right. So let us try to fit a model on this. Graphs, sorry, model, sorry, statistics, fit model, linear regression. Okay. Now, response variable. What is the response variable we can take? Let us try to make, I want to see the, what are the variables we have taken? Perceived discrimination and social connectedness. Okay. Let me take the response variable as a perceived, dependent variable as social connectedness, and then independent variable as a perceived discrimination. Okay, then just click OK. Your regression equation has come here. Okay, so it is 49.68011 minus 0.79188 into percent discrimination is your model, and your model is too low. That means the perceived discrimination score will help us to explain information about social connectedness only up to 28%. Model is too low. Okay, the relationship is too low, but still we can go with some other analysis now. Okay, what is that? In models, once we do with statistics fit model linear regression, the next we have to go with models, graphs. You can do any kind of a plots. Okay, you can do any kind of a plot. Numerical diagnostics, you can check. Let us try to do with graph. I want basic diagnostic plots. This is what I got. Okay, data is slightly skewed. Okay, and what is this? This is the residual plot. What does it mean? There is a high volatility in the data because the residuals, the difference of residuals should be uniformly distributed, but it is scattered around. Because of that, even if you see the standardized residuals also, but it's not that clustered, it is scattered. Okay, that's not correct. And if you see this, this is the Cook's distance to identify the outliers. Okay, so like this you can generate different diagnostic plots. Okay, influence plot you can generate. Okay, this is hat value. This goes little more mathematically. I don't want to confuse you here. Yeah, with normal QQ plot also we can decide whether the data is normal or not. Okay, whether the data is normal or not. So likewise, you can do a lot many analysis. Summarize the model. Okay, like this ANOVA table will come. All these analysis will come. Okay, and then hypothesis testing with beta, all these things. You can compare two models. You can do many other things. Okay. End of the session, kindly explain downloading R once more, please. I'm having trouble in downloading. Okay. Fine. I know I am done because I don't want to dump much. Okay. I have selectively taken some things and presented in front of you to make you exposed to the menu-driven strategies of our commander. Okay. Hope till now I made it a very comfortable platform to understand how to select the options and how to infer each and every graph. Is that fine? Inferring comes with practice. Inferring comes with practice because it is not general in sense. It varies from steady to steady, outcome to outcome. Okay. Now let me close all these things. Exit. No, I don't want to save any file. Don't save. Okay. Now I will show you how to download. Okay. Go to Google. There you type our latest version. Are you able to follow? Yeah. So latest version. Choose the first link, which is the actual source, actual source of this R. Now click on this link. Okay, if you are having Windows, then you choose this. If not, our latest version, you can type Mac. If you are using MacBook, you can type like this. Or if you are then Windows, then go for this. Now my system is of Windows. Then click that link and automatically it is downloaded yesterday. 1 second, and downloads. Yeah, it is there here. Okay. Now double click on this. Hope you are able to see my cursor movement. You're able to see that? Voice, please.
Yes, sir.
Yeah. Now click on this S. Now it will ask you to choose language. By default, it will be OK. I mean English. Click on OK. Then click on the next button. Again next. It is showing that it is already there. But for your purpose, I am continuing installation again. This wizard will come. Then click on next again. Accept defaults. Don't touch any other option here unless I tell. Then click on next. If you want the icon in the desktop, you can check this or leave it. Okay. Then click on next. It started installation. We're able to see the green bar.
Yes,
We're able
sir.
to see the green bar now,
Yes,
which is
sir.
progressing. No, it cannot say like that, Shubhashini. No, I'm in front of you only. I'm doing. No, that message hasn't come to me. Yes, you can use. That's what I said. Our latest version for Mac. If you type that file, you have to download. This file which I have downloaded is only for Windows. Now the installation is completed. Click on finish. Done. Now next what you have to do? Go to RStudio. RStudio latest version. Again rstudio.com will be there. Go to that. This web page will come. Go down. Free download. Click this download button. It will take you to this page. Now click on this download blue button. Already I have downloaded. It is also there. It is here. Do the same process. I mean, same steps, almost similar steps. What you have done with R. Clear? Now, any doubts you have? A command. Okay, 1 second. Command is, yeah. What command is? You have to go to packages, install, click the install button. You type rcmdr, select this and click on install button. Okay. See, installed. It got enabled and it started loading all the required packages. Now it gave a message that rcmdr successfully unpacked. Now it is into my local library. Okay. And thereafter I have to use this line. That's it. Library rcmdr, select, place the cursor in any area of this line. Click this run button. Click this run button. Now once you click this run button, it started loading all the sub packages related to R, and you can see a separate window got enabled. And thereafter you load the data and do your required analysis. Is that clear? Is that fine? If you are doing election analysis, how to compare two parties and which party is having edge for what reason? All these tests can be used. You can use Z-test. You can use some sort of a predictions if you want. All some sort of a basic analysis you can do from this software. Generally, I won't record all these things. Only the organizers have to give me a links. Then those things that can be done.
All the program videos are in the YouTube, sir.
Okay, okay. So
We
all
are
my
providing-
previous recordings also will be there in YouTube with the
Yes, sir.
respective organizers. Okay. If any doubt at any time, you can ping me. Okay, you can reach me out for any kind of a clarification, statistical clarification. Okay. So,
Okay, sir.
any doubts still? Any other doubts? Fine. So, let me thank once again the IQAC of Annamalai University and the team for giving this opportunity to interact with you virtually and sharing my some of thoughts where it can help all the researchers for better learning. Thanks to all the participants for patience listening and for what we say a quite learning interaction. Thank you one and all.
1 minute, sir. I invite Dr. K. Pravina, ma'am, Associate Professor, to propose thanks for this session, ma'am, please.
Good evening to all of you. I'm here before you to thank Professor Vishnuvardhan today for the nice session. He has given a nice exposure to the R programming. Today he has taught us how to use two-way contingency table in a step-by-step process using means, giving example of variables like gender, depression, homesickness, domicile, fear, culture shock, social connectedness. And he has also taught us how to, if the p-value is significant, then how then to go for post hoc comparison. He has explained the various types of graphs, box plot, plots of mean, scatter plot, then scatter plot matrix, 3D scatter plot, and how to interpret all this graph was very well explained by sir. I'm sure the participants would be highly benefited, and moreover, you're patient enough and very kind enough to answer to the queries of the participants. Thank you, sir, for sharing your expertise on behalf of IQAC. Thank you, sir, once again.
Thank you, madam. Thank you. Yeah.
Thank you, sir. Thank you.
May I leave now?
Yes, sir. Thank you.
Thank you. Thank you. Right.
Good evening, sir. Praksha, sir. Good evening.
Yes, good evening.
Good evening, sir.
Yes, good evening.
Shall we start, sir?
Yeah, I'm ready for it.
Okay, sir. As usual, I start with the quote for today's session. A true teacher would never tell you what to do, but would give you the knowledge with which you decide what would be best for you to do. Such an inspiring teacher is our resource person for today, Professor Paraksha. He is very casual in his approach of teaching, cites many examples. He has good command over the language. His content validity is excellent. We are happy to have you amidst us this evening for this session. On behalf of the IQAC-ANNAMALAI University, I welcome you, sir, to handle the session on correlation and regression. The platform is yours.
Thank you, madam, for a wonderful quote, actually. and connecting it with me. It was a pleasure to have that kind words for me. Thank you, ma'am. Yes. Good evening to all. I hope you have not taken a break in between. The participants probably for after 1.5 hours, it will be continuous. We'll be going along with next 1.5 hours. Okay, so we are now on the, I would say, last session for the topics that has been allotted to me. I'll be taking with the correlation and regression, which is actually very, very applicable, and it can be utilized. This technique is such that it can be utilized with probably any kind of data that you are dealing with, depending on the purpose of your or the objective of your problem. But correlation and regression is something that is talked a lot about, and I would say because it is talked a lot about, it is used a lot in probably in many scenarios, but still we are not still clear and have to be very careful about for using regression or multiple regression or correlation straight away, because the data is correlation is the simplest way to find out relation between the two variables. But we need to be very cautious whether correlation or chi-square should be used, whether correlation should be used. In regression also, we find out the model. We are ready with the multiple regression model. We are happy with it. But again, we need to check whether the same thing, then I'm repeating it again, whether the assumptions are satisfied or not. Because otherwise, if the assumptions are not satisfied, the results, the predictions that we make it from this multiple regression won't be of much use. It will not be that much accurate. So we need to check that also. So in this now probably 1.5 hours journey, I'll start with the basics of correlation and regression, and we'll end up with a multiple regression. And at the end, I'll also talk about how to check your assumptions, which are very, very essential for regression. And Vardhan sir was explaining about R and how to use R for data analysis. I would just add to that, that all the things that you do with SPSS or Excel can be done in R. Everything, all kind of analysis, exploratory analysis, graphs, hypothesis testing, correlation, regression can be done using R. And the only problem, I would say, or why people are hesitant to use R is because of the coding language. Because when the word code comes that they have to write down the program, then they are hesitant. If it is a menu driven software, everyone is happy with it. Okay, we'll go on with the menu and we'll do it. But there are pros and cons for SPSS also and for R also. So depending on how frequently you have to analyze your data, accordingly you have to choose your software. R is an open source, and now it is used in substitution for SAS software, which was once the only SAS was the only software which was permitted in the pharmaceutical industry for all the filings, that is US FDA and approvals and all. But now R being an open source, it is free. So now slowly and slowly, many countries are now accepting R in place of SAS. But still, the banking industry in US and Europe, they still insist of having SAS as a software for data analysis for banking industry and finance. Otherwise, now R has replaced almost, I would say, every domain in data analysis, and it has taken a good place for in place of SAS. Same way it is Python. Python is also the same. It is also coding, but it is used more by computer programming, more by the computer programmer or the person who is into the computer field. But if you learn R, you can easily divert yourself to Python also. Otherwise, if you start with Python, you can utilize R at ease, with ease only, because there are many packages available for it. So the point was the same thing, that because I read one of the question in the chat box, I would say all the things that you do it in SPSS or Excel can be done in R. And it is again a simple command that you utilize and we can go for that also. Fine. Correlation. So first of all, correlation is nothing else but the relationship between two or more quantitative variables. Two or more quantitative variables. A variable should be, it should not be a categorical variable. It should be a scale variable. So if there are two or more scale variable and we want to find out whether they are related to each other, then we will go with correlation. One more thing, correlation doesn't imply causation, because in many books they write down cause and effect relationship between the two variables is called correlation. But it is not so. It is not necessary cause and effect relationship. So correlation doesn't imply causation. So this is a very important statement. which many are misguided. If I take an example, simple, I say, price, okay, and the sales or the demand, we can say. Price and the demand. What is our general concept? That price increases, the demand decreases, or that price decreases, the demand increases. That we know it. That means if I make a change in price, I will get its effect in my other variable, which is demand or sales. So that means this is causation. This is called causation. If I say temperature and sales of ice cream, we know when the temperature increases, the sales of ice cream also increases. When the temperature decreases, the sales of ice cream also decreases. So again, cause and we get its effect. So there is a causation. If I take a data like population of India and average of car in US. Okay, average of car in US. There is no cause and effect relationship. Population of India increases, we know that, and average cars in, or average means mileage. The mileage of cars in US, we say because of this good engines, we can say, or because of using the solar, or because of using the electricity, we can say it is also increasing. But there is no cause and effect relationship, but still we can find out correlation between them. We can find out correlation, and we may have, if you have a data of population for last 6 months and comparatively the average or the mileage of cars in US for last 6 months, if you find out a correlation, we may have the correlation of 0.4. So correlation may be possible, but it is not necessary it means causation. Okay, such kind of correlation where the two variables are not having cause and effect relationship, such are called spurious correlation. Spurious or nonsense correlation means. Yes, Subhasini, it is not related, but yeah, it is said that it is a spurious correlation. So why I'm clarifying this, because many are having a misinterpretation that correlation means causation. No, causation is compulsory in regression, not in correlation. Here, any two variables, relationship between any two variables, if we find a number, that is called correlation. Okay, this is what I talked about, spurious correlation. Okay, correlation can be positive, it can be negative, and we know the examples for also that if temperature increases, the sales of ice cream also increases. So the change is in the same direction. Temperature increases, sales of the ice cream increases, so it is a positive correlation. If I say temperature and sales of woolen clothes, what will happen now? When the temperature increases, the sales of woolen clothes decreases. So there is a perfect, yeah, it is true. Yes, Subhasini, it is a negative correlation. What is zero correlation? If the change in one variable does not affect the change in other variable. That means if one increases and there is no effect on the other, then we say there is a zero correlation. So basically we can broadly classify into positive and negative. If there is a correlation but the variables are not having causation, then it is called a spurious correlation. Okay, now there are many ways to find out correlation coefficient. What is correlation coefficient? It is nothing else but a number. Yeah, Deepam, it is equal to 0. Yeah, right. So correlation is a measure of extent of correlation between the two variables. How much the two variables are related. That measure is nothing else but correlation coefficient denoted by R. Again, the same thing when we deal with population. If you go back to hypothesis testing and we deal with sample. So when we calculate on the basis of population observations, they are called parameters. And when we do the calculation based on sample, they are called statistics. Now, if I talk about correlation coefficient, R means a sample correlation coefficient, and rho, this is RHO. Rho is a population correlation coefficient, right? So it is, rho is also correlation coefficient. Perfect, Sri, right? So correlation coefficient is denoted by R, but that is for the sample. But if it is for the population, we denote it by rho. This is the symbol that is used for it. So what is correlation coefficient? Ultimately, it is a relationship which measures the extent of relationship between the two variables. And there are many ways to find out correlation coefficient, or many probably methods, Carl-Pearson, Spearman's, and many more. But the most famous is Carl-Pearson. Carl-Pearson is frequently used measure or the formula. Does the number also say about how effective the relationship? Yes, number obviously will say. Yeah, you are very right. If I say R is equal to 0.7 and R is equal to 0.1, so it shows that there is a high correlation over here and there is a low correlation over here. So numbers do signify. Actually, correlation coefficient signifies two things: the degree and direction. So when I say degree is 0.7 and direction is positive, if I write down R is equal to minus 0.2, degree is 0.2, direction is negative. So correlation coefficient gives you two things: degree and direction of relationship between the two variables. Now again, the same thing that we did in hypothesis testing, that we actually have to do the population survey, right? It is not feasible, so we take a sample, we find out mean from this, and we assume that will be the same answer for mu also, right? This is hypothesis testing for single mean. Same thing is done for correlation also. I'll give you an example. My statement was that temperature and sales of ice cream are having a relationship. There is a high correlation. So what I can do it, I can take it for around about 200 or 365 or 300 different days. So for 300 days, 1, 2, 3, and so on, I'm taking the temperature, or I'm not for 30 days. Let it make it think simple. 30 days, I'm measuring the temperature and I'm measuring the sales of the ice cream. And from that 30 days, my answer comes to say 0.65. Now I want to conclude whether this 0.65 is a significant correlation, because this is based on the sample. 0.65 is a significant correlation that can be checked by hypothesis testing. Normally, we don't check. We say 0.65 is a high correlation, means it's okay, we are satisfied. And 0.2 is a low correlation, so we'll say there is no correlation. But it is not true. This 0.2 correlation, it is based on only the sample of size 30. Okay, so we need to check whether there is a significant correlation or not. And for that, hypothesis testing comes into the picture over here. And we can use SPSS for hypothesis testing of correlation also, which ideally, whenever you show the number of correlation coefficient, you should support it by hypothesis testing that we have checked there is a significant correlation. How it is done? Step 1, rho is equal to 0. That means there is no significant linear correlation between the two variables. Alternative, rho not equal to 0. That means there is a significant linear correlation between the two variables. So here it will be always taken as rho equal to 0. That means there is no correlation, and rho not equal to 0 means there is a significant correlation, right? So this is how we can do correlation testing using SPSS. This is the formula for test statistics T, R into root of n minus 2 upon root of 1 minus r square. Compare with the degrees of freedom and find out the table value. You can do it. If it was for single mean, if you recollect the formula, it was x bar minus mu divided by standard error. It was sigma root n. This was for single mean. Same way, there is a formula for correlation coefficient. But as we are using software, no need to remember this formula. We can do it directly. SPSS at one click will give you all the things. Okay, let me take a data now. So I have a data, I'll just show you that also. It is a data for body temperature of 100 adults along with the gender, age and heart rate. So my data will be having temperature, body temperature. It will be having a data of gender, that is male, female, age and heart rate. I want to find out, obtain the correlation between what it is asked, correlation between, I want to check this, correlation between body temperature and heart rate. What is the correlation between these two, body temperature and heart rate? And we want to check its significance also. Is there any significant correlation between them? That we can do it using SPSS. So now I'll show you the data, body temperature, how it looks like, the data. Here it is. This is the data, gender. This is gender. So that is a categorical variable. Age, scale variable. Heart rate is a scale variable. Temperature is a scale variable. So for finding out correlation using Carl-Pearson, we need two scale variables. So the question was to find out whether heart rate and temperature is having correlation. And if yes, then whether it is significant or not. That we want to do it. So now using SPSS, I hope you are now knowing how to import the data. I'll just show you how to do that. It is very simple. Okay, this is my file. Excel, I've opened up SPSS. So file, open, opening my data, right? In that data where I have stored it, I'll just open that. Here it will show only SPSS file. So here at the bottom, it should be all files. So at over here, correlation regression, it is body temperature. I'm opening. So whether in Excel, there are different sheets. So which sheet you want to open? It is the first sheet. Yeah, it is the first sheet in which the data is stored. Check out this gender, age, heart rate and temperature. Then you need to check the variable type. Gender is a string. Okay. Age is numeric, scale. Okay. Everything is fine. So always form a habit. Once you import the data, whether SPSS has understood the data properly or not, you need to check using variable view. Right. Now I want to find out correlation. Correlation between what? The question was asked for body temperature and heart rate. Okay. I want to do it with body temperature and heart rate. So analyze. In that correlation, bivariate. Which variables you want it? Suppose I want between heart rate also and temperature. So I want correlation between these two. Options, you can check, nothing is required for it. Everything else is, if you want Carl-Pearson, so it is Carl-Pearson. If you want Kendall Tau, it is for categorical also. It is Spearman's and you can find out according to that. Fine. This is okay. Here you will get this kind of cross step. It will not give you a single value, mind well. SPSS won't give you a single value for two variables. What it will give you, it will give you the output in this way. Yeah. This is what I've done it. This is the output. This is the output, how it will give you. So what does it shows? That correlation between heart rate and heart rate is 1. Now it is always 1. Correlation between the same variable X and X is always 1. Correlation between Y and Y is always 1. correlation between X and Y is same as correlation between Y and X. So here you can see correlation between heart rate and temperature is 0.448. Between temperature and heart rate is 0.448. It is the same thing, right? So I'm getting a correlation between temperature and heart rate as 0.448. Now 448, you feel it is less than 0.5, so it is not a high significant correlation. Diagonally same, yes, it is diagonally same. So R is 0.448. Now you have to check its p-value. We'll do the conclusion in the same way. What is the p-value for it? 0.000. What was our null correlation? What was our null hypothesis? Rho equal to 0. That means there is no significant correlation between heart rate and temperature. What was H1? Rho not equal to 0 means there is significant correlation. What is the value of P? 000 means less than 0.05. Less than means what? H0 is rejected. So you can see we are following the same step, nothing new in it, whether it is correlation, regression or nothing. It is one and the same thing. So we say H0 is rejected. That means H1 is accepted, means rho not equal to 0. This means there is a significant correlation. So 0.448 is also a significant correlation. That is what we can get it over here. Clear? This is how correlation can be found out between the two variables. Now it can be found out for more than two variables also. This means I can go with analyze, correlation. Okay, I can include all the three variables. I'll be getting 3 cross 3 cross step, 3 cross 3 table. I'll be here. It is. This is what I'll be getting here. So now you can see correlation between heart rate and temperature is 0.448. Correlation between temperature and age is minus 0.132. Correlation between age and heart rate is 0.104. So you can compare multiple variables together. So it is not necessary that always you can do it with two variables only. You can compare 3, 4, 5 scale variables together and you can have a cross tab, and simultaneously you can make a conclusion for the relationship between two variables. Achha, what does two tail means? Suhasini ma'am, the two tail is the hypothesis that we have taken. Here, this is rho not equal to 0. So this was for two tail. If you recollect, this is two tail value that we are getting it. This value. If I wanted the rho is positive, that means it is one tail. In that case, I have to take half of P. I have to take half of P. If you recollect, whenever it is one tail, we have to take half of the P value if it is given for two tail. I hope you can recollect it. Yes, Menkaji, you are right. So this is how we can do correlation and we can check its hypothesis testing also. This is what we have done it before. Any doubt for this? I hope you all are with me now. Rho is equal to not 0. Yes, very good, Menkaji. Anyone else? Okay. So now we go with regression. So in short, if I sum up the correlation part, what you have to remember, correlation is nothing else but a relationship between two or more variables, which should be scale. Correlation doesn't mean causation. Once you get the correlation coefficient value, it is not necessary that high value of correlation means it is a better correlation. You need to check it with hypothesis testing. Even 0.35 can be a significant correlation and 0.65 cannot be a significant correlation depending on the sample size. So we need to check with hypothesis testing that whether there is significant correlation or not. So whenever you write down R, support it by hypothesis testing result in your reports, in your paper. Okay, now talking about regression. You can use candle also, but generally when there are two scale variables, go for Karl Pearson. Now, what is regression then? So regression is nothing else but a relationship between two or more variables. But which type of relationship? Here it is compulsory that it should be a causation. It should be a causation. Like the example that I took over here, temperature and the sales of ice cream. So this is called independent variable in a very simple language, and this is a dependent variable. So statistically, we call it as independent and dependent. We can also say this is nothing else but outcome variable. You can also say this is nothing else but a response variable. There are different words that can be used depending on the domain that you are using it. Here, this is independent. This is called predictor. Okay, this is also called features, explanatory variable, predictors, and so on. There are many different names that you can use it for it. But the simplest way is sales depend on temperature. So this is a dependent variable and this is independent variable. Non-statistically, in real life, we call it as a predictors and outcome or response variable. So relationship between such variables, response, that is a dependent and independent variable, is called regression. No, Sanjay ji, we cannot take, see, null hypothesis is always equal to. So this will always be rho equal to 0. And alternative will always be rho not equal to 0. So in any hypothesis, even if you are checking the mean, this will be mu equal to mu 0 only, or p equal to p0 only, or mu1 equal to mu2 only. We'll always take an equal to sign. So here also, null hypothesis rho will be always 0. We cannot take it not equal to 0. Okay, Sanjay ji? Right. Now, which type of regression to use? Because there are many regression. And if I'm not exaggerating, you can say in industry, if you are proper with or having a good command over regression, I would say 70% of the total analysis you can do it. If you have a good command of regression, 70% of the applied statistical data analysis is nothing else but regression. Right. So first, dependent variable, independent variable, which type of regression to be used and what type of relationship we are talking about. So if one variable is scale, other is also scale, that means independent variable is scale, dependent variable is also scale, then we can go for simple linear correlation, regression. So we are assuming there is a linear relationship. Both are scale. If one is scale, that is dependent is scale, independent can be scale or categorical. Independent can be scale, it can be categorical. And if there are more, right? If there are more, that means I have an equation, or I'll take it in very simple way now. Y, x1, x2, x3. Okay. So here y is scale, x1 is scale, x2 is scale, and x3 is categorical. Still we can go for multiple regression, right? So here in that case, we can go for multiple linear regression. So independent variable, the x variable can be categorical, it can be scale, or it can be both. Then still we can go for a multiple regression. Now, if independent variable, it is okay, scale and all, but if dependent variable y, I'm putting the points again over here, x1, x2, x3. x1 is scale, x2 is scale, this is say categorical, and Y is also categorical. I'm sure all have not used such kind of things. Y is categorical. Like I want to check whether, I suppose I'm in a banking sector. I'm a manager of a bank. I want to decide whether I should give a loan to a particular person or not. That means I want to check whether he will be default or he will not be default. Okay, he will be default or he will not be default. That means my Y is a categorical variable where it is a kind of binary, yes, no. Whether a customer will purchase or he will not purchase. Whether the mail will be opened or it will not be opened. So if my dependent variable is categorical and independent variables can be scale or categorical, this kind of scenario, then I can go for logistic regression. Yes, no kind of thing. Then I have to go for a logistic regression. And if it is binary, then I have to go for binary logistic. If it is categorical, but not binary, it can be more, right? It can be more. Then I have to go for multiple logistic or multi-normal logistic regression. Like I'll show you an example. Y, X1, X2, X3. Suppose this is scale, this is scale, this is categorical. And I want to decide why. I want to decide in which category I have to classify this person. I want to classify this person in high risk zone, medium risk, low risk, or no risk zone. I want to classify that person because I want to disperse the loan. I want to classify. I just don't want to classify that whether it will be default or not. I want to classify into different groups. So that means there are multiple category for this. In that case, we have to go for multiple logistic regression. So these are the simplest regression I have considered over here. There are many more. There can be non-linear also. This all I'm talking about linear. It can be non-linear also, right? But I'm not talking that right now. I'm talking about the simple, which are frequently used are this kind of regression. Out of that, we are going to discuss today about this part only. I'm giving you just an idea that this is also a regression which can be used, and we can discuss it at some other stage. But this is simple and multiple. So now to make it clear, which type of data will be having it? My dependent variable will be scale only. My independent variable can be scale or it can be both. So I'll be dealing with that. If there is only one independent variable, it is simple linear regression. If there are more, then it is called multiple linear regression. Make sense? Yeah? Clear? Yeah, so right now I will not be taking it logistic regression. That is what I'm saying. Yes, Vasima, he will be taking logistic regression. Okay. Now we'll go further in this. So we'll focus on linear regression only now, and then multiple. Okay. See, in simple, if you refer simple books or even simple notes, then they will give you regression in this way: y is equal to a plus bx. You might have come across this kind of regression line, right? But this is again a regression line for a sample data. Ideally, theoretically, how it should be written when we talk about a original regression line, you can say, okay, a plus b0, but there will be an error term in it. Why there will be an error term? Because you'll not be able to exactly predict your y based on x and based on this model. There will be some error to it. So that error we have to include over here. Okay, error, or it is also called residue, or it is also called an error. What it is, I'll just give a diagrammatical view so that it is more clear. Yeah, here it is. So if I'm having, okay, let me explain it first of all over here only, then we'll go with that chart. What is ideally done, I'll just take 5 more minutes just to go with the technicality, how, by the way, regression was You might be knowing that regression was found by Galton. And this is based on principle of least square sum of errors, which was given by C.F. Gauss. So what is actually all this principle of least square sum of errors? What did Galton give? How he found out? I'll just be taking just a few minutes for that. Suppose there are two variables, X and Y, right? And my points are, I'm plotting a scatter plot for it, right? I'm getting a scatter plot. This is my scatter plot of X and Y. Now, what is method of that is C.F. Gauss says, you draw a line passing through nearly all points, not necessarily all points, nearly all points. So say this is line 1. Okay, line 1. Now for line 1, what I will do it, I'll find out sigma, or I'll find out E square. What is E square? E square is a perpendicular distance between the point and the regression line. That means this is the point and the perpendicular distance over here. This is the error. I expected this point, but actual point is this. So this is an error. Say suppose the error is 3. This is an error. Say the error is 1. This is an error. Say error is -2. This is an error. Error is -1. This is -1. Say this is -2. So on. Calculate error for all the points for regression line 1. Say for line 1, I'm getting 3, I'm getting -2, I'm getting 1, and so on. So for line 1, I'll take a total of all the squares of error, sigma E square. I'm taking square so that negative values are ignored. So suppose sigma E square comes to 250. So for line 1, my sum of squares of error is 250. Now what to do? Now you draw some other line. Now draw other line. Suppose I'm drawing another line, say L2, and I'm drawing it in this way. I feel that this is my regression line. This is L2. Then again, I'll find out all the perpendicular distance. I'll find out an error. Okay, all perpendicular. So for line 2, same way I found out sigma E square coming to 195. Then same way draw third line. Find out sigma E square. A line that gives the minimum value of sigma E square is considered to be the best fitted line. A line which gives you the minimum value of sum of squares of error is considered to be the best fitted line. This was the concept given by Galton. This is how regression line was developed. Getting it down? And see the name of the principle. It is called method of least square only. It is very famously called method of least square. But actually the whole name is method of least square sum of errors. What is this? Sum of squares of error. And what is this? Least. So the line which gives the least value of sigma E square is considered to be the best fitted line. This is how the regression is developed. And that is why I'm saying you can see any line you take, there will be some or the other error with it. And that is why the concept of error should be always there. A plus bx plus there should be some error. There will be an error. When you actually, if it is an actual data, there will be an error. If you manipulate the data, it's okay. There cannot be any error. But if you manipulate, if you are having actual data, there will be an error or an residual term. And what is the error? Actual value minus the estimated value. That is an error. This is a little bit technical, okay, but just those who wanted to understand the concept, I have given a brief idea about it. Yeah, so this is beta 0, beta 1. It depends on you, whatever you like. In certain books, you will find out beta 0, beta 1. Certain books, you will find out B0, B1. But here also what we are doing it, for population linear regression line, we'll say it is this. For sample, we can say this is nothing else but B0 plus B1x1 plus B2x2 and so on. We can say that. So it is depending again of population and the sample concept. This is a line that I talked about. Yeah, diagrammatical representation. If I draw the regression line this way, the intercept means distance between the point of intersection and origin, is nothing else but your intercept, this intercept. The slope of this line is nothing else but beta 1. Beta 1 is the slope of a line. Okay, that is the slope of. So that is a diagrammatical interpretation of your regression line. This means if I have y is equal to 5 plus 2x is my regression line, then this means if you draw the graph, the line will pass through 0, 5 because my intercept is 5. And the angle, tangent of the angle, or we can say the slope of the line, difference between y upon difference in x, that is nothing else but slope is 2. Okay. Achha, by the way, how to interpret regression coefficient? Suppose I say my beta 1, I say that my beta 1 is 1.5. Can anyone say what does this mean? I'm okay. I'll still simplify it for you so that it becomes easy. I'm talking about a regression line y is equal to a plus bx. And for the data, I'm getting the answer 5 plus 2x. So my byx, which you might have used the terminology, byx comes to 2. What does this interprets? Byx is 2 means what? Yeah, outlier will be identified using scatter plot, or it can be identified even using the box plot, or there is another technique also for it. We'll do it today. Outliers. Yes, Sumasini ji, y on x, but what is the interpretation? Byx is equal to 2 means what? Byx is equal to 2 means if there is 1 unit change in x, if there is 1 unit change in x, there will be 2 unit change in y. If there is 1 unit change in x, how much there will be change in y is denoted by byx. See how useful this is, how practically it can be used. I'll explain. I'll go back to the same example, temperature and ice cream, sales of ice cream. Suppose I've collected for 30 days temperature and ice cream. I've collected the data and my R comes to 0.7. What does it shows? That there is a high degree positive correlation between temperature and the sales of the ice cream. Now that actually we can do it without even calculation. We know, it is a common sense that when the temperature increases, the sales of the ice cream will increase. When the temperature decreases, the sales of the ice cream will also decrease. So there is a correlation. Then what is the point of doing this? Actually, practically, business-wise, what is more important for me? I can say the temperature increase, sales of the ice cream also increases. What is useful for me as a businessman? How much my sales of the ice cream will increase. If I have a statistical technique which gives me that answer, then it is more useful than only correlation. Correlation is saying there is relation. What makes sense? That is common sense. I want in my business that if the temperature increases, my sales of ice cream will increase by how much? That answer is given by byx. That means, suppose this is your x and this the sales of the ice cream is y, and my byx comes to say 1500. What does that mean? That if the temperature increases by 1 degree centigrade, the sales of the ice cream will increase by 1500 units. My sales of ice cream will increase by 1500 units. Now, this is something important for me. Why it is important? Now think practically. We know the meteorological department, weather forecast, they can give us a temperature. Suppose the weather forecast is given that in next 7 days, temperature will increase. And that is in today's newspaper also, the temperature is going to increase. So in next 7 days, right now the temperature is at 20 degrees centigrade, and the weather forecast says that in next 7 days, the temperature will be 25 degrees centigrade. So weather forecast has given me a data that my temperature is going to increase by 5 degrees centigrade. And this my data is saying that for 1 degree increase, my sales will increase by 1500. That means for 5 degree increase, my sales will increase by 7500 units. If this figure, rough estimate I'm having it, what I'll do, because it is expected that next week the temperature will increase, there will be more demand of ice cream. I should stock my ice cream. I should have more production in my ice cream so that when there is a demand, I can have my ice creams ready for it. That is why regression is more practical compared to only correlation. And so correlation and regression always goes hands to hand. Only correlation is meaningless. It has to have, in practical terms, the practicality which can be done with the help of regression. It makes sense? Perfect. So this is how actually regression is useful. That how much the change will be there. So assumptions. First, it should be linear, because I'm saying y is equal to a plus bx. So this is a linear format. That means regression model is linear in nature, or y is equal to beta 0 plus beta 1x plus error. This is linear in nature. Quadratic means what? Y is equal to a plus bx plus cx square. This is quadratic. There is regression. Quadratic equation also is there. Non-linear. This is also regression. Y is equal to a b raised to x. But this is not linear. This is exponential. So right now our assumption is the linear model is linear in nature. And we have to check this at a later stage. Errors are independently distributed. Errors, not the variables, right? Errors. Errors are normally distributed. Again, not the variables. Errors. So mind well all this. Errors. Errors are having equal variances. Again, it is errors. So in regression, the assumptions is for errors. And when we can get an error? Once we have a model, once we have a regression line, then only we can have an error, and then only we can check this assumption. And that is why in regression, we check the assumptions after model building. While in hypothesis testing, what we were doing it, we were checking it beforehand. Before going with the hypothesis testing, before using the formula, we were checking the assumptions because that was for the variable. This is for errors. And that is why now when we take an example, you will see that first we'll develop the whole model, we'll create a model. Once the model is ready, once we have a model, then only we can find out the errors. Practically, what is error? I'll explain. Say, a very layman example I'm taking it, very layman example. Suppose X values are 1, 2, 3, 4, 5. My Y values are okay, this is the case. Okay. I'm taking but that will actually give you the idea about what is actually errors. Then what to do? Go with the regression model. And suppose my answer comes to 5 plus 2x. My regression answer is coming as 5 plus 2x. Now I can find out error, because what is error? Actual value minus estimated value. Actual minus estimated. What will be your estimated value? substitute x is equal to 1 over here. So when I take x is equal to 1, what is my model giving me? My model is giving me, so that is estimated value 5 plus 2, it is 7. So my model is giving me 7. If I substitute x is equal to 2, what is my model giving you? 9. When I take x is equal to 3, my model gives me 11. When I take x is equal to 4, 4 to 8 plus 5, 13. When I substitute 5, 5 to the 10 plus 1, 10 plus 5, 50. So this is the estimated value. So what will be error now? 0, 1, 4, minus 1, 1. This is my error. So that error, the error that this part that we are getting it should be independent. It should be normally distributed. It should have equal variance. Now you tell me when I can find out error. I can find out error only after I have a model ready. That is why all these assumptions will be checked after model building. Make sense? Okay, great. Sure. You are very right. If that I'll be taking care of, that once you get the model, say for example, temperature and sales, X and Y, and I'm getting a model, Y is equal to say 1500 plus say 50X, something of this kind. Then this is a model. There are certain, I would say, there are certain things that you have to keep it in mind, that this model is applicable only for the data set that is available. If your observation goes beyond this, that means here suppose my temperature is say from 20 to 40, then this is applicable for the temperature 20 to 40. If it goes like 0 or if it goes to 45-degree temperature, then this model may not work. So it is always the word of caution, as it is rightly mentioned by one of the participants. The word of caution is this regression model is based on the data that is available. So in certain books, you may find this is used for interpolation, not for extrapolation. That means you can find out any estimate within this value from lower to higher. But if you take a very extreme value, then this model may not work. So it is applicable only for the given range of data and for a particular time interval. Okay, we'll go further now. This is the method that I explained in detail. This will be too technical otherwise for you. Yeah, I'll go with this now. Coefficient of determination, R square. Suppose I have my data, say again the same thing, temperature and sales. This is X, this is Y, and my R square comes to say 0.7. What does this mean? This says that 70% of variations, 70% of variations in sales is explained by temperature. So in other words, there is 30% still left out. So there, it is not only temperature that is affecting sale. There are some other factors also that you should include to make a better model. So how much the dependent variable is explained by the independent variable, that is measured by R square. Say for example, you are also including, this is one of the variable, you are also including say temperature, and I'm also increasing the price. I'm also including the competitor's price, the difference between the price of our company and the competitor's price, difference between that. Okay, average difference between them. So if I am including more variables, then it may happen that my R square from 70, that is 0.7, it may go to 0.8. This means 80% of the sales is or can be explained or depends on, or in other words, you can say depends on temperature, price, and some other factor. That is a price difference. This is what we can do. And that is why when I deal with multiple regression, we will say that we will include all the variables. First of all, we'll include all the variables so that our R square is better. And then we'll remove all the variables which are not significant. And then again, we'll run the model. So when you are starting afresh, that means when you are before collecting the data, first of all, depending on your dependent variable, try to include as many independent variables as you can feel while collecting the data. You feel there are only two variables which is depending on y depends on, but try to get more, because the more variables you are including it, there is a better chance of having a very proper model for it. If you only include one of the variable, you'll get a model, but your prediction, your estimation will not be proper. And that is why, depending on your response variable, you should include as many predictors as you can. Collect the data, let the computer, let the software do the analysis and tell you, okay, out of this, these two are not important for us. But according to your practical knowledge, according to your domain knowledge for the response variable, try to collect as many variables as you can. Okay, now there was one question, probably it was asked right in the beginning of my few sessions, adjusted R square. Now in softwares, output will give you two things, R square also will be there and adjusted R square will also be there. Now the question comes, what is this adjusted R square and why it is different from R square? How it is different from R square? Then the next question comes, should we look R square or should we look adjusted R square? I hope these are the same questions you are also having it. Yeah, you should have this kind of questions. Yeah. Now I'll explain that adjusted R square so that when output is discussed, there is no query left out for you. Now adjusted R square is a modified version of R square, and that is the formula R1 minus 1 minus R square n minus 1. So this is the formula where n is total number of observations and small p is the number of independent variables and so on. This is okay. Formula is there. This is fine. What is important for us to understand it? So what does this says? This says that if I take only, this is my dependent variable y, I'm including only one variable, it may be possible that my R square and adjusted R square will be almost same. It will be same. When I take two variables, x1 and x2, that means I'm adding more information in my data. I'm adding more variables which are explaining my dependent variables. In that case, R square will always increase. If you include the third variable, that means you are adding some more information which will explain your dependent variable. So R square will again increase. And so on. If you go on adding the variables, R square will go on increasing because you are adding an information for explaining your dependent variable. But are these variables significantly explaining your y? Are this variable worth including in your model? That is explained by adjusted R square. If the variable that you are adding, suppose I have added which variable over here? I have added x2 over here. So if the variable x2 that you have added is contributing a lot to explaining y, then your adjusted R square will also increase. But if you add x3, and x3 is not contributing a lot to my dependent variable y, my adjusted R square will decrease. That shows that x3 is not worth including in your model. Getting the logic now? So actually adjusted R square should always be looked at when there are more than one independent variable. If there is only one, no point looking at adjusted or adjusted R square. But if there is more than one, then you have to look at it, what happens to R square? What happens to adjusted R square? So see, this is how it will happen. I have taken just a test case for it. One variable, my R square is 72.1, my adjusted R square is 71. If I add, that means I'm including two variables, my R square increases, my adjusted R square also increases. I'm including the third variable, my R square is increasing, but my adjusted R square is decreasing. I'm adding the fourth variable, my R square is still increasing, but my adjusted R square is decreasing. Okay, so that means adjusted R square shows you whether your model is improving by adding a new variable or not. And that is important for us. And so adjusted R square becomes more important compared to that of a simple R square. Are you all with me? Good. Okay, we get it. Yeah, multiple, I explained about it. There will be more than one independent variable. Chalo, now we'll go with the case study. We'll actually do the data. Okay, Durga ji, Vashanta, Aruna ji, Sanjay ji, fine. I'm taking the same data. Okay, I'm taking the same data. Subhasini ma'am, I will be taking that. Don't worry. How to check the assumptions? If you recollect what I said, when to check the assumptions? After the model is developed. So I have not yet taught how to develop the model. I will do that. And I would be the first person to say check assumption. Whether it is for hypothesis testing or correlation or regression. I would be the first person. So that is an important point. So it's good. Just remind me if I forget that particular important aspect. Okay, the question was, this is the data I have shown you: gender, age, heart rate, temperature. Built a linear model for body temperature using heart rate. So this becomes a body temperature using heart rate. So now I want to build a model only with one independent variable, that is heart rate. You may have more variables, but right now we are focusing only on one independent variable, and that is heart rate. That is heart rate over here. This is your X and this is your Y. Okay, right? Sure. How to do it? Very simple. In analyze, regression, go to linear. You will get this pop-up box. Decide what is dependent and what is independent. So my temperature was dependent, heart rate was independent. Right? I'll show it actually also, practically also, and you will get this out. So we'll do it now. This is how it is done. We have already loaded the data. Where to go for? Analyze. In regression, linear. Go in linear. Once you click on linear, this is a pop-up box. First is the dependent variable. Which is my dependent variable? Temperature. Independent. So you can have more than one. If you include more than one, it will be multiple. If you include only one, it will be simple. So right now, I'll start with simple. So I'm including this. That's it. Okay. You will get the answer. Regression is ready. Model is ready. So that model building is not a big thing. Working out the data on SPS is not a big thing. But to understand the data, understand the problem, understand the output, and interpreting the output is more important. You can see in one click you got the answer. So that is not a big deal. But now the outputs that we are getting we are getting this output, we are getting summary, we are getting ANOVA, we are getting coefficients. And how to interpret this is more important for us. Yeah, inference is more important. Now we'll go with it one by one. One of the output will be this R square and adjusted R square. But this is simple only. This is simple. One variable is only included. So you can go with R square. No need to check with adjusted R square. So my correlation coefficient is 0.448. That we had done it before also. In correlation checking, we had done it. But now I'm going with the model. So it is R square. So what does this shows? That R square comes to 0.20. What was my Y? Temperature. It will be written over here. Predictor is heart rate. My X is heart rate. What does R square is equal to 0.20 suggest you? What is the interpretation? That the change in temperature is explained, or 20% of the change in temperature is only explained by heart rate. Still, there are other factors which is affecting 80% of your temperature. Okay, so what is this case? Again, I repeat. Change as a 20% of the change in temperature can be explained using heart rate. Remaining at 80% is still unexplained. So that means we have to include more variables to get a better prediction for it. So next we get is this output. This is an Anova output. Anova, Raju sir might have talked about in one-way Anova and two-way Anova. So this is the same output we are getting it, but the difference here it is within and between it is same thing. So instead of writing down here, it will be regression and it will be residual and total. Check out the p-value. P is 0, 0. It is less than 0.05. Less than means the model is good. Enough evidence to that the fitted model is good. That is significant. This is not the best one, but it is good. As per the data, the model is good. Because the p-value, Anova gives you the interpretation that whether a model is good fit or not. So this means our model is fitting good to the data that is given to us. Okay, it fits well. This is the interpretation of Anova. That is the only interpretation. So the outputs that we are getting in this is one, from which we will say R square, how much it is explained. The second is Anova will say how the model is fitting to the given data. And the most important is the coefficient. These are the coefficients. If you recollect our simple line, y is equal to a plus bx. Y is equal to a plus bx. A is what? What is y equal to? A is a constant. What is b? Coefficient. That is given to you. Constant is 92.391 and heart rate coefficient is 0.081. Okay. Now we want to check whether this is significant or not. These are the coefficients. Or we can say this is beta 0 plus beta 1 x1. So whether beta 0 and beta 1 are significant? Because without any statistical support, we are not saying that, okay, 92 is good and 92 is bad. We cannot say that. We have to justify it. How to justify is again hypothesis testing. We did it in correlation also. What was the correlation? At rho is equal to 0, no significant correlation. Rho not equal to 0, that means there is a significant correlation. Same way, here also there is a process. Beta 1 is equal to 0, that means not significant. Beta 1 not equal to 0, that means it is significant. Then there is a formula and you can use a table and we can find out. But no need to do this. It will be directly given to you. What is it shows? You can see the heart rate. Constant is fine. What is the heart rate? It is 0. So what is the p-value for heart rate? 0.000, which is less than 0.05. Less than means what? H0 is rejected. H0 is rejected means what? H0 is rejected means what? Beta 1 is not equal to 0. That means regression coefficient for heart rate and temperature is significant. Getting it? The same thing that we did for correlation, is done for regression also. We need to check this. And that is why the table automatically gives you that output, whether this regression coefficient is significant or not. So what actually this is, for that only I've explained this. The T formula will be over here, and the significant is the p-value that is given over here. So p-value means heart rate beta 1, that is 0.081 is significant. If it is not significant, you have to drop out that variable that will deal in multiple regression. You have to drop out. Okay, Sapna, you are asking what is standardized and unstandardized. We have to use unstandardized only. It is actually the ratio, this upon this. But no need to go for standardized beta value. Standardized beta will be so that there is no constant. There is no constant. If you don't want a constant in your model, like your model was y is equal to a plus bx. But if you don't want this constant, you have to go with the standardized beta. But practically, we have to use this only. So what you can say, regression model now is 92.391 plus 0.081 of heart rate. So my temperature, my model is 92.391 plus 0.081 heart rate. Now, what is the advantage of this? Once you have this, suppose you have created such data for all the individuals of India, because geographical location wise also this changes. Suppose you have done this for all the individuals means by taking a large sample from India and you have generated this model. Then if you have an individual who says that my heart rate is say 80, okay, substitute over here, you will find out what should be the temperature. If someone say my heart rate is 60, substitute over here, you can able to predict the temperature for it, body temperature. So estimation and prediction can be done based on the model that you have generated. Okay. Shall we go further? Okay, good. Oh, so 6:48 now. I'll be a little bit fast now. Now, checking the assumptions. What were our assumptions? Linear, independent, but errors are independent. Errors are normally distributed. Errors are having equal variance. We'll check all this using SPSS. So pay attention now, how to check the assumptions. Perfect. Okay, Suhasin. First, now I'm checking with linear. So what to do? In your data, go with graphs. Your data is there. Go in graph, legacy, then scatter plot. Okay, directly also in graph, you can go with the scatter plot if you want. But if you go in the scatter plot, you will get this as a pop-up box. What you want on y-axis. So my independent variable is marked. Then click on OK. I'll get my scatter plot. If you click on the scatter plots, this will open. It is called chart editor. I'll show you this also. This is a rough way of doing it. Graph, legacy, scatter plot. I want a simple scatter plot. Define temperature, heart rate. Click on OK. This is my output. Okay. What I'll do, I'll double click on this. When I double click on it, a new pop-up will be opened and it will show my chart editor. In that, I will put on this part. That means here, which will give me the line. If I click on this and I get a line on it, straight line on it, that means this is a linear. Two variables can be considered as a linear. Actually, assumption is not to be checked for this, but still the linearity can be checked using this rough way of doing it. Next part is assumptions is errors are independently distributed. Then again, what you have to do in linear regression, enter temperature, enter heart rate, click on statistics. It will show you Durbin-Watson residuals. Again, it is errors. So we'll go with residuals. That means residuals means errors only. Durbin-Watson. Click on that. You will get this answer. Check out the value of Durbin-Watson. 1.804. Right? It is 1.804. It is close to 2. If it is close to 2, that means errors are independently distributed. Easy? फिर से? Okay. Analyze, regression, linear, temperature, heart rate, statistics. In statistics, go with Durbin-Watson. Click on continue. Click on OK. You will get the output for it. This is the Durbin-Watson output model summary. If it is close to 2, we say the errors are independently distributed. Yeah, 2 is fixed. It is a standard value for comparison. It is always 2. Then I want to check normality also. I want to check whether they are normal, errors are normally distributed and they are having equal variance or not. Then again go with this temperature, heart rate, click on plots. Here on plots, this is very important. When you click on plots, it will show this menu. On that, take this is predicted value, PRED, predicted, right? And residual, RESID is residual. So take predicted value on X and residual value on Y. Click on the normality plot also over here. So at one click, you will find out the 2 values. I'll check it again. I'll show you over here. Analyze, regression, linear. This is ready. In plots, what to do? One is normality can be done with normality plot. Then what to take on y-axis? Check it out. What to take on y-axis? Residual. Okay, on y-axis it will be residual. Y-axis it is residual. On x-axis it is predicted. Click on continue, click on OK, you will get the output. So this is the output that you will be getting it. This is output. This is the QQ plot, quantile plot you are getting. If the points are very close to the diagonal line, we say it is normal. Okay, it is normal. What is homoscedasticity? That means variances are equal. Errors have equal variance. Here you can see there is no pattern in the data. They are all random. If you find a pattern of this kind, maybe like a funnel kind of thing, points are in this kind of thing, or point of this kind of thing, or a point this kind of thing, any funnel kind of thing, or any particular pattern you find it out, then we say variances are not equal. Here we'll say variances are equal. Here this is 0. This is 0. So points towards upper part and lower part are almost same. Points towards left hand side part and right hand side part are also same. There is no pattern for it. So we can say that the variances are equal. This is how all assumptions are checked. And no book has mentioned this, all the 4 assumptions, how to check. Clear? Wow, great. I see the numbers are also increasing. Participants are increasing. Good. Yes, it should include. Assumptions, we should include it. Oh, good question. Deepaji, if assumptions are not met, depending which assumption is not met. If it is normality is not met, either you can go for non-parametric, there is non-parametric regression also, or I would suggest transforming our variable, values of the variable, either taking square root or square, and then we can do it. We can go with that. Again, if this homoscedasticity is not met, then there is a procedure for it in which we can convert our variable which is not, or our errors which is not coming to equal variances, we can do it for equal variances by transforming our variable. So there are techniques in which we can do it for checking this. Okay, collinearity, Subhasini, I think, okay. Actually, it is right, but collinearity comes into the picture when there are more than one independent variable. Here, there is only one independent variable, so there is no need to check the collinearity. Now, when I take multiple regression, I will have to check the collinearity. Because ultimately, what is collinearity? Collinearity is a high correlation between independent variables. But here, there is only one independent variable, so there will be no correlation. But your point was right. No need to check in simple, but you need to check in multiple. Okay, shall we go further? 3 minutes are left. I'll take 10 more minutes. Probably every time I have to extend my session. I don't know. But I wanted to be clear with your concepts, because in 1.5 hours to finish all the regression concepts are very difficult. But I thought it is better to finish with the concept rather than to just finish with regression. It is necessary to check the assumptions here. So second data. I'm taking now, this is mean arterial blood pressure. So in simple words, it is blood pressure. Dependent variable, age, weight, body surface area, duration of hypertension, basal pulse rate, measure of stress, and these are my independent variable. 1, 2, 3, 4, 5, 6. Right? These are the 6 variables that I have included. I thought that blood pressure depends on this many variables. If you feel there are more variables, you can include, collect the data, and do the analysis for it. Right now, I've included these 6 variables. Body surface area means आप कितने मोटे हो देखने में. Weight wise नहीं. There are many persons who are not having that much weight. The water and air content are more, but their body surface area is more. That also affects hypertension, whether you are having hypertension or not, basal pulse rate, and the stress, whether you are stressed and what is the level of your stress. This is the data, right? This is the data that you'll be having it. Okay, this is the data. What we'll do, simple, the same logic. We'll go with analyze, regression, linear, enter all the variables that you have. All the dependent variable, dependent is only one, that is blood pressure. All other variables you enter in this independent part. Okay, now I'm giving a little bit overview of it, because exactly it will be done in the same way. We have done one in detail. This can be done in the same way. Click on OK, you will get this output. My R square is 0.9952 and adjusted R square is 0.993. Okay, so we will consider 0.993 only. There is no much major difference between these two. But what does this shows? That 99.5% of blood pressure can be or is explained by stress, body surface area, hypertension, age, pulse, and weight. That is a huge number. Good explanation. 99.5 means almost blood pressure is explained by these variables. So that is what we can interpret from the data, that it is a very high percentage of explanation. Okay, so 99.5% of variation in blood pressure is due to so and so and so. Second is ANOVA. Again, check what is the value of P. It is 0, less than 0.05. That means it is a good fit. Our model fits well to the data that is given to us. Third is important, coefficients. Now, this is very, very important. Understand it now. Yeah, we can go with stepwise. I'm going with a backward integration. That means I'm including all, removing it, whichever is, I'm not doing it one by one. I'm including all together. And I would suggest this is the easiest way of doing it. You can do it, but that will take time. Include one variable, then include second variable, include third variable, or include all and then remove one by one. That also can be done. But I am of a habit and I would suggest that do it this way only, include all, then check the significance here. So here you can see this variables, the value of P is greater than 0.05. What does this mean? Greater than 0.05 means H0 is accepted. H0 is accepted means what? Beta is 0. Means there is no significant regression coefficient. So you can exclude these variables. I repeat my point. Yeah, non-significant. Perfect. Once you have the coefficient, check the significance. Here it is significant. So that means age is important, weight is important, body surface area is also important. Here this is 0.265, which is greater than 0.05, greater than 0.05, greater than 0.05. So that means you can exclude this from the model. Because practically in real life, model with lesser number of variables explaining more is better. That means here you can see it was 1, 2, 3, 4, 5, 6. If I use 6 variables, my R square is 99.5. But if I'm using 3 variables and still I'm able to predict 95, this model is considered to be better. Because with a slight decrease in the explanation, there is a major decrease in the variables that has been done. So the process is, once you include all, remove these variables, which are not significant. I'll run that model again. These are not significant. I'll run that model again and I'm getting the new model. I'm excluded that and I'm getting a new model. My R square comes to what? 0.993. So you can see after excluding that also, my R square is still 0.993. What was that initially? 0.995. It is still 0.993 or adjusted is 0.992. That means even after removing that 3 variable which were not significant, I'm able to explain 99.3% of variation in the body, in the blood pressure. Then ANOVA, again p-value, it is less than 0.05, so it is a good fit. Here you can see now all variables, age, weight and body surface area are significant. Now my model is ready. What will be the model? Regression model will be what? Blood pressure is equal to minus 13.401 plus 0.718 into age, 0.896 into weight, 4.553 into body surface area. This is my regression model. This is called multiple regression model. Model is ready. Simple. Yeah, we are considering adjusted R square. But see, adjusted R square, the value is not, there is not a major difference. This is 0.993 and this is 0.992. Okay, so that is not a major difference. That is why even if I write down 992, it doesn't matter. So adjusted R square is almost same. That is why you can use either of that. Okay, model is ready. What is my next step? Once we get a model, our next step is to check the assumptions. Okay, assumptions. There will be one more assumption of multicollinearity. So Hasini madam, you were talking about, that has been included now because it is multiple regression. What to do? Now, again, first is linearity, graph, legacy, go to the scatter plot. In scatter plot, there are more than one variables. I'll be going with the matrix plot. In matrix plot, same way, include all the variables over here, all variables. All means what? Blood pressure and the 3 significant variables. Click on this, you will get this matrix plot. Double click on it, click on the line, you will get almost, you're getting a linear part for this. Next is normality and all. Where to go for? Here, where you run the regression, go into statistics or go into plots. If you want to check the normality, go into the plots. Then what to do? Here, normal, and here, residual and predictors, the same process. Here you can see the points are almost nearer to this, so it is a normal distribution. Here you can see this is 0, so to the left of this, points are almost same, left and right, and here also to the top and the bottom also it is same. So we say that homoscedasticity assumption is valid. Then Durbin-Watson. So go to statistics. We want to check what we want to check now, whether the errors are independently distributed or not. Go to Durbin-Watson. Answer is 1.537. It is close to 2. So we say errors are independently distributed. Now the next part comes multicollinearity. Multicollinearity. Where to go with this? Same case, go with statistics. Here it is collinearity diagnostic. Click on that. If you click on that, you will get a new table over here. Check for VIF. VIF. Okay, this is VIF. We have to check this. VIF is nothing else but variance inflation factor. Variance inflation factor. So if this value is it again, this is changing from books to books. In certain books they compare with 4, certain books they compare with 5, certain books they compare with 10. But I would suggest if VIF is between 1 and 10, if this value is between 1 and 10, that means there is no multicollinearity issue. If suppose you are getting this as 11.2231, 11 point, that means there is a multicollinearity issue with this. You have to remove this age. You have to remove this age. And another way to observe, this is again not given in any books, but another way to observe that if there is a multicollinearity, this standard error will be inflated. Means there will be a big value of standard error. Inflated, it will be a very big value. Here you can see it is very small value compared. So here VIF also is coming in the range. So that means there is no correlation between the independent variables. This is how multicollinearity can be checked. So this is how all assumptions are done. I'm done now. Yeah, finally it's 7:09. I said I will finish by 7:10. I'm done with it. Again, this presentation also will be uploaded on my blog. If you want, you can take it from there. Statistics for you. I have again uploaded all my previous sessions also there. And this was all using SPSS. Same way I will be uploading for R also. Same way it will be uploaded for Excel also at a later stage. So every session it can be done with Excel, SPSS, R, Python, and same parallel sessions can be done.
Yes, sir. Thank you, sir.
Yes,
I will unmute the participants so that they will ask if there is any questions.
Yeah, sure.
If you have any questions, you can ask sir now. You are unmuted.
I'm getting the feedback also from the chat box, so thank you for that. So this was my last session, and I would say that if you have any query, you can reach to me through my mail, and wherever you are stuck up, we are there to help you out. For academicians, we are always ready to help.
Questions are there in the chat box, sir.
Okay, there is one question. when to use other correlations. So depending on the variables that you are dealing with, when there is one, suppose the data is ordinal. Right now we are dead with the scale variable. When the data is ordinal, then we have to go for Spearman's and all other parts.
ഞാൻ ഇന്ന് പോയപ്പോ ഇവരുടെ ക്ലൈമറ്റ് ഭയങ്കര സ്റ്റൈൽ ഉണ്ടായിരുന്നു.
Ranking wise, if that is the data, we have to use that.
No other doubts?
I think there are no doubts. So thank you, ma'am, for inviting me, for sharing all the typical concepts, which I hope that I have fulfilled your expectation and the participants' expectations.
Sure, sir. Is there anyone to speak?
If anyone want to say something, okay, that is all.
Shall we
Good evening, sir.
propose thanks for this session? Is there any?
Good evening, sir.
Yeah, good evening.
Yes.
This is Subhashini Sataravan from IIT Gandhinagar.
Okay, yeah, it's the same state.
I've been pestering with so many questions to you all the sessions.
Nani, that shows that you are keen to learn. That's good. Questions are always welcome.
Thank you, sir. Thank you very much. Actually, I'm a research scholar, just started this year. There are so many questions in the, like we haven't decided much of the research topic and all that. It was amazing 4 sessions from you, I think. From the start of 19th, I think you started with the introduction. Then on 24th, we had hypothesis testing, 23rd and 24th. Then today we had this correlation regression, and all 4 sessions were amazing and we could learn a lot, sir. It was sort of advanced statistics, I think.
Oh, thank you.
I'm actually a management student. We have learned all this homoscedasticity and collinearity in theory.
Oh.
But we haven't done it on graph or calculation like this. So this has really helped, and I think I'll be all of us, all on behalf of all the participants, and I have to thank you for giving us this much of high knowledge.
It's my pleasure. It's always.
Thanks a lot, sir.
Thank you, ma'am.
Hope the participants also will feel the same what I had told now. And if any queries, we'll contact you.
Anytime. Yeah, surely we are there to help you. Surely.
Till that doctor degree comes before our name.
Yeah, best wishes for that also. Yeah. So from the research scholars, I hope and I wish that more numbers of PhD and doctorates come out.
Yes, sir. Thank you, sir.
Quick.
Thank you.
Okay, I think.
Now I request Shailila Madam, the organizing secretary, to propose a formal vote of thanks.
Okay, ma'am. Thank you, ma'am. Sir, your journey to our program is highly remarkable. Your sessions were highly impressive to the participants because of your simple examples that you have used. Your teaching, doubt clarifications are highly commendable, and we thank for the data set you have provided to us. Thank you for your commitment to the task assigned. You have been exceptionally well. On behalf of IQAC and on my behalf, I express my deep sense of gratitude for sharing your expertise and enlightening our participants in various topics of data analysis. Thank you very much, sir. We are very fortunate to have you as a resource person for our programs. We will still collaborate with you in future endeavors. Thank you very much, sir. Thank you for coming.
Thank you. It's my pleasure, and thank you for inviting. And Shailina ma'am is always there. Probably this is the second or the third session that we are having with probably the ANNAMALAI University IQAC department. So it is always pleasure to be a part of such kind of sessions that you all organize. Thank you.
Thank you, sir. Thank you very much for accepting our invitation. Thank you very much. Hoping to keep in touch with you in our future endeavors, sir.
Sure. It's my pleasure. Thank you, ma'am.
Thank you, sir.
The examples what you are telling is very good, sir. Particularly to catch very easily the teaching terminology also very good, sir. Thank you very much, sir. Very kind of you.
Please introduce yourself, sir.
Yeah.
Person who spoke just now, please introduce yourself.
My name is Srinivas Rao. I am a PhD scholar from the Meher University.
Okay. Thank you, Srinivas, sir.
Thank you, madam. Thank you, madam. Once again for you. You are introduced a very good sir for us. Without asking the questions, he is clearing all the doubts. That is credit goes to Annamalai University, and sir is very good. Thank you, madam. Thank you very much. Thank you, sir.
Thank you. Thank you.
Hello, sir.
Yeah.
Sir, thank you. Sir, actually, this is Amit Kumar from Karnataka, sir. Research scholar, VSK University, Ballari.
Okay.
So far, when we go through these sessions, it is somewhat we felt it is completeness in statistics. Okay, but my tension is that how much affordable these statistics to other social science when they never gone through this all the things earlier, and at a time when we are looking these sessions, whether is all the things are affordable for our research, whatever the techniques and tools, is that this is somewhat some dynamo in our mind, and how you encourage your teaching itself is a greater encouragement for us, sir. And we have even gone through your sessions, everything, but it was very complete. We feel we feel that we have big taken away from these sessions, and hope so you may further organize. We are always encouraged and hopeful to join these sessions. We do it, sir, but the question is how affordable it is to other social science students when they never gone through these all the statistical concept, and when we are going through the first time. And of course somewhere we might have heard it, because all are not statistical subject teachers and statistical dealers, but to extents they know it. But when we go through intensivity, there is no end for this. But whether it is affordable to research that we can do these all the concepts in our research. So this is what some small.
Amitji, I got your point, and thanks for the kind words also for it. And I would say, Amitji, it is not necessary that all the concepts that has been covered in this particular training session of 15 days should be a part of your research. Again, your purpose, the data that you have it, the objective that you have it, based on that, the statistical technique will be used. So not all. It is not necessary that you have to include everything over here. Talking about affordability means I can understand that everyone is not aware of statistics so much in detail. But
Yes,
such 15 days program or even a 5 days workshop can help a lot to at least clear the concepts and to understand the data and apply the statistical technique.
Sir, one question I want to ask you in related to my research, sir. Can I ask you if you just permit me?
I think it would be great if you send me a mail for it, because otherwise the others, I think there are
Fine,
other.
sir. So what I asked you, sir. Otherwise, okay.
You can send me the mail. You can send me the mail. I'll be surely happy to answer to that.
Sure, sir. I have received your mail ID. I'll just post the mail related to my concept. No, I want to just some clarifications. How this research topic, what statistical concept will be set to research topic? This my title topic. I want to just small clarifications required from you, but I will mail you, sir, as per your permission. I will do it, sir.
No issue.
Sir. Thank you very much, sir.
Because I can see that Shailina ma'am and other madams and also all the other are still at their office. And so it is almost 7:20. So it is better that we don't disturb their office timings.
Okay,
right, sir. Thank you. I will not waste, sir. I will not waste much of the time of all the participants.
Yeah.
Sir, thank you very much for excellent presentation, and we learned many things out of this. And the most important thing which we all could recognize is testing of hypothesis is highly essential. As far as though we are doing any type of analysis, testing of hypothesis would be highly essential. Sir, it was really very helpful for all of us. Thank you very much.
Thank you. Thank you. Yes, madam. I think we'll leave now. Selina, ma'am.
Yes, ma'am. Yes, sir. Thank you, sir. Thank you so much.
Thank you. Okay. Bye.
Thank you, sir.
Okay.